Thank you for listening to my presentation. I would like to talk to you about our SaaS project that also included the establishment of a Center of Excellence at UC Davis called the Agricultural Water Center. The title of our project is Sustaining Groundwater and Irrigated Agriculture in the Southwestern United States under a Changing Climate. And the short name for our project is Southwest Groundwater CAP. In many parts of the US where irrigated agriculture is heavily practiced, we're pumping groundwater at a rate that is faster than the rate at which it is recharged by either rainfall or streams. An example of this is the Ogallala or High Plains Aquifer in the central United States, or the Central Valley Aquifer System in California, as well as the Arizona Alluvial Aquifer System. Therefore, there is an urgent need to develop ways to use groundwater sustainably in irrigated agriculture. This slide shows changes in irrigated agriculture over the US in a period of 20 years, from 1997 to 2017. A red dot represents a decrease of 1,000 acres of irrigated agriculture, and a blue dot represents an increase of 1,000 acres of irrigated agriculture in a given region. We can see that there's been a significant decrease in irrigated agriculture in the Western US, and an increase in the Eastern US, which has traditionally been humid with sufficient rainfall. The reason for the decrease in irrigated agriculture in Western US is mostly lack of water. And this has been true in California as well as the Ogallala Aquifer region. And as we'll see, irrigated agriculture is very, very important to our total agricultural production. On this slide, we see the percentage of farms in the US that are irrigated in a dark shade, and the percentage contribution to total crop sales of farms that are irrigated. Although irrigated farms are less than 20% of the total, they contribute close to 50%, and in some years more, of the total crop market sales in the US. This tells us that irrigated agriculture is a very important part of our production system, of our ability to produce enough nutritious food to feed everybody. However, we have seen that we cannot use groundwater in a way that is unsustainable. Therefore, we have a big challenge on one hand to find ways to use groundwater sustainably, and on the other hand, to practice irrigated agriculture that is key to meeting the grand challenge of producing enough nutritious food for the world's growing population. Therefore, our project came up with a vision statement. And our vision statement states that we would like to alleviate groundwater overdraft and water quality deterioration in major aquifer systems. As you can see, we would like to alleviate the situation where we deplete our aquifers and trigger problems like land subsidence or poor water quality. We'd also like to address the problem of non-point source pollution that is attributed to management of agro inputs in agriculture, as well as enhance the resilience of the socioeconomic resilience of communities that depend on irrigated agriculture in the Southwestern US, as well as develop and promote agroecologic management practices, as well as technologies develop and evaluate technologies that can allow us to use groundwater sustainably while intensifying irrigated agriculture, sustainably intensifying irrigated agriculture. Just like all the other CAP projects, we're involved in research, education, and extension. To learn more about each of these components of our research of our project, please visit our website at the URL shown above. We have a large multidisciplinary project team from various states, California, Arizona, New Mexico, as well as various institutions. If you'd like to learn more about the different team members, please visit our project website again at the URL here at the bottom. Under research, we are broken in 3 components: groundwater, sustainable agricultural systems, and social economics. Under groundwater, we're looking at increasing groundwater quantity, improving groundwater quality, improving hydrogeophysics, understanding of our groundwater aquifer systems, and evaluation of groundwater policies. Under sustainable ag systems, we're looking at climate change impact on agriculture, soil health, water management, nutrient management, and desalination of brackish groundwater. And under socioeconomics, we're looking at regulations, impact of regulations on both groundwater and irrigated agriculture, drinking water impacts, multi-land benefit repurposing, as well as alternative water supplies and technologies. And in education, we are looking to leverage the Hydroland project to develop modules for K through 12, as we'll also plan to work with minority serving institutions, high schools, elementary schools, and project-wide programs in our participating states, as well as the private sector. We will also leverage the land grant system of all our participating universities, including the University of California Agriculture and Natural Resources, the University of Arizona Cooperative Extension, New Mexico State University Cooperative Extension, as well as the 4-H programs. We'll work with a wide range of private sector partners, including startup ag companies, consulting firms, grower coalitions, nonprofits, and commodity boards, as well as government, local, state, and federal. We have 3 study areas: the Central Valley of California, the Panal Active Management Area, and the Lower Rio Grande in New Mexico. This slide summarizes our project. We'll be looking at the drivers of groundwater and irrigated agriculture sustainability, which are climate change, regulations, and markets. We'll develop a range of models: hydrology and geophysical models, biophysical models, and socioeconomic models that will allow us to evaluate a range of climate adaptation strategies like groundwater recharge, soil health, and other management practices. And then this integrated system will allow us to do a systems analysis of both groundwater sustainability, irrigated and irrigated agricultural sustainability. This is how our project is organized. We have an executive committee of objective leads and institutional heads, an advisory board, and an independent evaluation team, as well as a large number of investigators, collaborators, and partners. Thank you very much, and look forward to collaborations with many of you at this workshop. Thank you.